This problem contains a traffic light which is suspended from two cables here. Now the system is in equilibrium, it's not moving, and we have an angle here of 30 degrees with the vertical. So we're asked to find both tensions in the cable. So what we're going to do is we're going to first of all draw a free body diagram of the system. So we're drawing a free body diagram of this traffic light. So we isolate the traffic light by itself, and then we draw all the forces acting on it. So I'm going to put this traffic light up here. Now, first of all, the easiest force, as we always say, is mg, which acts downwards. Now, we've told the mass is 50 kilograms, so it's going to be mass times gravity, 50 g. That's acting downwards, pulling it down. Now we have cables to hold it up. The first one, like this, so that cable is pulling on the traffic light, keeping it upright, so it's pulling it that way. And the other cable is pulling it this way. Now, we know this angle here is 30 degrees, so we're going to go ahead and resolve this into two forces that have the equivalent effect. Now, the reason we do that is because we want everything to be straight in x and y. So this is x, this is y, but this is a combination of the both. So first of all, we're going to resolve, and then we have everything in x and y. So to resolve this, you're going to have two components, one going in this direction and one going in this direction. And this angle here is 30 degrees. Now, since this force here is unknown, we're going to call it T1, and we're going to call this T2. Since this component is next to the angle, this is the cosine. So it's the force, T1, cosine the angle, 30. This component here you can see is not in contact with the angle, so therefore this one is the sine component. So T1 sine 30. Now what you've done is you've effectively replaced this with two equivalent forces. So you can go ahead and delete this one, and we have two forces that have the same effect as that one force in the middle, except now we have a situation where everything is in y and x. Now, since this thing is balanced, therefore up must equal down and right must equal left, and that's how we're going to find everything. So first of all, let's do the up equals down, because that will give us T1. There's only one missing. So in the y direction, T1 cos 30 is equal to 50 g. Divide both sides by cosine 30, you get T1 equals 50, g is 9.81, divided by cosine 30. That gives us a T1 value of 566.38 newtons. Now, let's go ahead and find T2. So just like before, we're going to make this equal to this in the x direction. So T2 equals T1 sine 30. Now, we know that T1 is 566.38 multiplied by sine 30. So from this, we can now say that T2 is equal to 283.19.